Okay, today we're going to continue to look at factoring polynomials. Now, we've already touched on this some, and we might have discussed this previously in other classes as well, but when we're factoring a polynomial, we have several different methods that we may use. And depending on what of these basic methods we're going to use is determined, it's depending on what the number of terms are in the polynomial. First off, anytime we have any polynomial, the first thing we're going to do is check for GCF. We always check for GCF first, so no matter what's going on, no matter how many terms are there, we will always do that. You'll look for GCF, and if there is one, you're going to take it out, basically reversing the distributive property after you identify what that GCF is. The next thing we're going to check for is if we have two terms. If you have two terms, there are a couple of different ways that you can go with it. If there are two terms, you might have what we call a difference of squares, where we have two terms that are both being squared and they're being subtracted. Remember, the word difference means that they are being subtracted. If they're being added, we do not have a difference of squares. So looking at something where we have a difference of squares, it's a real quick factor. We just use a pattern where we take the two roots or the two square roots of both terms. In this case, it would be x and y, and we just put those in two separate binomials. The first one would have a plus and the next one would have a minus, and then that would be a factored out version of that polynomial. Another method, of course, would be if you have a sum or difference of cubes, and there's a pattern for that. Obviously, a sum of cubes would be two numbers to the third power being added together. In that case, it would follow a quick pattern that we've learned in class already: x plus y times x squared minus xy plus y squared. And we'll look at some of those today when we practice our problems. Obviously, if it was a difference of cubes, it could be either one of these, and if it was a difference of cubes, the signs would be changed a little bit, but it would still have that same pattern. Finally, if it's got three terms, which is probably the most common that we'll be dealing with right now, we're going to use what we call the trinomial method, and that's where we multiply the first and last terms and try and find combinations that will form the middle term. We'll look at some examples of that in a minute. And there are some situations where we'll have four or more terms, in which case we're just going to form groups and take GCFs out. And I'll show you how that works in a minute as well. All that said, remember always we're going to check for GCF first, and then we'll just flow through these different methods and identify which one works best for the problem that we have. Let's look at a few examples. You've been given a sheet of problems. We're going to work out some of those problems on that sheet as we go, and hopefully get you started on the right path as you're trying to complete these problems in class. So first of all, we're going to look at this example, which I believe is number 1 on the list. And number 1 on the list gives us 24a squared b squared minus 18ab. And again, like we've said, the first thing we're going to check for in any situation is the GCF of that problem. Okay, so we'll take a quick look at this polynomial here, and we're going to identify any numbers that might go into both of these polynomial terms. The first one being 24a squared b squared, and the second one being 18ab. Now, as we look at these, you may identify that your GCF between 24 and 18, that would be the biggest number that goes into both of those, is 6. In addition to that, we have an A and a B in both of these terms. Now, what we'll do is we'll take the biggest one that we'll divide into both of those. It usually ends up being that it is the lower of the two degrees between the two. So if we have an A squared and an A, we will have a GCF that includes a to the first. If we have a B squared and a B, we will have a GCF that includes a B. So the GCF of this polynomial is 6ab. We'll find that this term divides into both of the terms there. So what we're going to do once we identify that GCF is we're going to write it down here and put a set of parentheses next to that. And we're just going to divide 6ab into both of the terms. Now if we divide 24a squared b squared by 6ab, that's going to leave us with 4ab. And you can double check yourself by multiplying that back out. Of course, it would give us 24a squared b squared. The next thing we're going to do is we're going to divide 6ab into 18ab. And I'll give you a second to think about it. And hopefully you're seeing that we get a 3 when we divide that. So our factored out polynomial is going to be 6ab times 4ab minus 3. Now again, like we've said already in class, it's important to understand that if I was to multiply this back out, which we don't have to do, but if I was to do that, that would give me 6ab times 4ab would be 24a squared b squared, and 6ab times minus 3 would be minus 18ab. Of course, that's what we started with up here. It's the same thing. So what we're really doing when we factor polynomials is we are unmultiplying them out, okay? We're finding the parts that were multiplied together to get that polynomial. It's very important information for us to know in a lot of cases. So that said, our final answer again is 6ab times 4ab minus 3. All right, next example. We're going to move on to number 7 on your worksheet. Number 7 is a polynomial that's got 3 terms. Now, as we look at this, we see, first off, we would want to check for a GCF. And as we look at these 3 terms, is there any term that will go into all 3 of them? Well, hopefully you're seeing that there is not. So we have no GCF, so we're going to go ahead. We do not have a difference of squares because we don't have 2 terms. We don't have 2 terms, so we know we don't have a sum or difference of cubes. We do have 3 terms, so we're going to use what we call the trinomial method. So let's look at what we do in the trinomial method. The first thing we're going to do is take our first term and our last term, and we will multiply them together. That would be 12y squared. Now once we get that 12y squared, we're going to list off all the ways to multiply to get 12y squared. So we could multiply together 1y and 12y. We could multiply 2y and 6y. We could multiply 3y and 4y. Now of those combinations of numbers, we want to identify the pair that will add to make 7y in the middle, positive 7y that is. So as we look through those options, we should be able to find a combination that will add together to make positive 7y. And I think if you look hard enough, you will find that 3y and 4y will combine to make positive 7y. So we're going to use a positive 3y and a positive 4y to make that positive 7y. So we're going to now rewrite this problem. We're going to take this whole deal and we're going to rewrite 7y. So we've got y squared, and we're going to take that 7y. I've got the plus 12 on the end. I'm going to take that plus 7y and I'm going to split it into 2 pieces. Those 2 pieces would be the 3y and the 4y that we determined will add up to make that 7. It's a very important part. Now once we do that and we split this into those terms, we're going to make 2 groups. Okay, we're going to take a group of the first 2 and we'll take a group of the second 2. And we will now look for the GCF in each of those 2 groups. The GCF in our first group between y squared and 3y would be y. And as we pull out y, that would leave us with y plus 3. The GCF in the next group, 4y and 12, I'll give you a second, is 4. So as we pull that GCF out, we take 4 and we'll divide it into both of these terms. That would leave us with y plus 3 again. Now you can see that we have a y plus 3 and a y plus 3 on each of these two terms. So what we're going to do for our final answer is we're going to take that y plus 3 out of the problem. Now, as we remove y plus 3, the only things we would be left with would be yn plus 4. So that would be the other factor of this polynomial. So our factored out polynomial will equal y plus 3 and y plus 4, or times y plus 4. And again, if I multiply those out with the FOIL method, you would find that we would get the same thing that we started with, which was y squared plus 7y plus 12. Okay, moving along, we're going to now move on to number 14. And hopefully by this point you're noticing how many terms there are, and you're already checking for a GCF. And we would check to see if there are any numbers that are going to divide into all three numbers, 2, 13, and 24. Are there any variables that are with all three terms? We don't have one, so we do not have a GCF at this time. Then we'll check, we don't have a difference of squares, we know, because there's two terms. There's also, there's not two terms, there's three terms. So we know we don't have a difference of squares or a sum or difference of cubes, but we do want to use the trinomial method because we have three terms. So we're going to take, again, you may remember now, we're going to take our first and last terms and multiply them together. That would give us negative 48x squared. And we're going to list off all the ways to multiply to get negative 48x squared. So that would be 1x and 48x, 2x and 24x, 3x and 16x, 4x and 12x, and then finally 6x and 8x. 48 is a number that has a lot of different combinations to multiply to get it. So you want to make sure you get all of those. Make sure you take your time and don't miss any, because a lot of times the one you miss might be the one that you need. So what we're looking for at this point is something that will subtract, since that is a negative there on the last term, we're going to subtract to get positive 13. So we're going to look closely and see if we can identify any combination of numbers that will subtract to get positive 13. Okay, and hopefully you're noticing that 3x and 16x will subtract to get positive 13. Now the question we need to ask ourselves at this point is, what signs do we need to put on these numbers to get positive 13 out of this? That's right, you should get a negative 3 and a positive 16. If we combine negative 3 and positive 16, it will make positive 13. So here we go, we're going to rewrite our problem. We've got 2x squared, and we're going to put two things in there to replace that positive 13. So in other words, we're breaking positive 13 into two terms. Those two terms would be negative 3x and positive 16x. And once we do that, we're going to make two groups. And our two groups are going to have GCFs. We're going to identify the GCFs in those two groups. The first group having a GCF of only x. X is the only thing that comes out of those two. The 2 and 3 don't have a GCF between them. So as I divide x into 2x squared, that leaves me with 2x, and I divide x into negative 3x, that would leave me with negative 3. So we've got x times 2x minus 3. Then we go to our second set, and we look at 16x and minus 24. The biggest term that will go into both of those would be a positive 8. So when we divide positive 8 into both of these terms, we'll get 2x and minus 3. Again, hopefully you're noticing we have 2x minus 3's there, which fits our plan perfectly. We're going to take out 2x minus 3, and as we remove that 2x minus 3 from what we've got, we're going to be left with x plus 8. So our factored out version of 2x squared plus 13x minus 24 is 2x minus 3 times x plus 8. Now remember, one key point that I haven't really discussed too much is, if we look at this problem, the last term had a minus sign there. Okay, that was telling us that we were going to have to subtract these two numbers to get our middle term. If you look back at the previous problem, we had an addition sign on that last term, and that told us that we should be adding 3 and 4 to get our middle term. Okay, very important aspect that we need to make sure we're aware of as we do these. Okay, let's look at our next example. Kind of brings all this into play. As we look, we've got, hopefully by now we're seeing that we do not have a GCF. We don't have two terms, so we're not going to use those, and we are going to pretty much go to the trinomial method. Trinomial method is, again, is 3x squared and negative 10. We're going to multiply those together. We get negative 30x squared. Now, by this point, you're probably saying, man, why does he keep giving us all the trinomials? They're very common. We stumble across these quite a bit in our class, so we're going to make sure that we know how to factor them, because they're probably the more complicated of all the methods. So as we recognize the first and last term, we're going to make negative 30x squared. We list off the ways to multiply and get that. That would be 1x and 30x, 2x and 15x, 3x and 10x, 5x and 6x. So we're going to now be looking for the combination that will subtract to make positive 13. Again, we look at the last sign, or the sign of the last term, and it tells us whether we should be adding or subtracting. So you got to be careful with this one, because it could go a couple ways. Okay, as you're looking at it, you might see two combinations that can make 13. If I make 3x and 10x, my combination that I'm going to use, I would have to add those to get 13. However, we don't want to add 3 and 10, because that's not going to work out for us. So the combination that we should be using is 2x and 15x. 2x and 15x will subtract to make 13. And we definitely want to subtract in this problem, because our signs have to be opposite of each other in order to get this last term to be negative here. Okay, so as we continue, let's look at the signs we would use. To get a positive 13, I'm going to need to arrange my signs on 2x and 15x so that I have a negative 2 and a positive 15. Negative 2 and plus 15 will make positive 13. So now that we've found that, we're going to now rewrite our problem. So we've got 3x squared. We're going to take that 13x and we're going to break it into two pieces. And then we're going to use that combination in our factoring. So the 13x is going to be broken, like we said, into negative 2x and plus 15x. And once we do that, we're going to make our groups. So we've got our first group, we've got our second group. By this point, hopefully you're already looking for the GCF of the first group, and it is x. The GCF of the first group is x. We take that out. That leaves us with 3x. And we divide x into this, and that leaves us with minus 2. The GCF between 15x and minus 10 is positive 5. And we divide that out, and that leaves us with 3x. We divide it in there. We divide 5 into negative 10, and that leaves us with minus 2. So again, we have 3x minus 2 repeated there as a factor. So we will pull it out of the problem. And as I remove that from the problem, I'm left with x plus 5, which is my last factor, or my second factor for this polynomial. So 3x minus 2 times x plus 5, if we multiply that out, that would give us 3x squared plus 13x minus 10. Okay, hopefully you're getting the hang of this trinomial method. There are some other methods. As we look at number 21, we notice that we don't have three terms. But we're still going to go and check for GCF. as we look, we see there is no term that goes into both of those terms, so we don't have a GCF. But we do have two terms, so that means we're going to be identifying our problem as probably a difference of squares or a sum or difference of cubes. Well, as we look, this is x squared and 64. These are both perfect squares. And this minus sign is telling me that we have a difference. So because we have a difference and they're both perfect squares, we are dealing with a difference of squares. Now when we deal with a difference of squares, all we're going to do is we're going to take the first term and identify the number that is being squared to get it. That would be x. If we take an x and square it, we get x squared. Might take you a second or two, but hopefully you also realize that if we take an 8 and square it, that would give us 64. 8 times 8 is 64. So once we identify these two pieces, all we're going to do to factor this out, and it's really simple as long as you identify what you're dealing with, you're going to take the first term and write it as the first term in both parentheses. You're going to take the second term and write it, and then we write a plus and a minus. And this pattern works for any difference of squares that you have. And it's very quick once you identify it. We have a difference of squares. We know there's going to be the two square roots with a plus and a minus, anytime. Here's another one. This is back to number 5 on the worksheet. As we look through the list, we start off checking for a GCF. Now, if you look at 24AX and 9AY, you might see a GCF between those two, but it probably does not come out of 40BX and 15BY. So there's not really one number that comes out of all 4 of those terms, unfortunately. So what that tells us to do is that we can't use the GCF method. We know we don't have 2 terms, so we're not going to use those methods. And we know we don't have 3 terms, so we're not using the trinomial method. So we are going to go with the grouping method, which means that we're going to take these 4 terms and we're going to split them into 2 groups. So I'm going to make a group here, and I'm going to make a group here. Now, if you've mastered the trinomial method, we're really doing the same thing, but we don't have to do all that stuff at the first where we multiply the first and last terms. So as we look at this, we find the GCF between 24AX and 9AY. Well, you can probably realize that the GCF of 24 and 9 is 3. These also both have an A in them, okay? So we're going to take that A out as part of the GCF as well. So we'll divide both of these by 3A. When we divide 24AX by 3A, that leaves us with 8. The A's cancel out and leaves us with X. When we divide 9AY by 3A, that leaves us with 3. And then the A's cancel out and we are left with a Y. I'm going to move this whole thing down. Oh, it doesn't all want to go together. Let's see. I guess you get to laugh at me a little bit. Just to get a little room. So we have 3A times 8X minus 3Y. And we are now going to look at the second parentheses, the second group. And that second group we can remove, or we have a GCF of 5, but we also notice we have a B on both of those terms as well. So we're going to remove a 5B as our GCF out of that group. Now if we divide 40BX by 5B, that's going to leave me with 8X. And if I divide 15BY by 5B, that's going to leave me with minus 3Y. Now, you might already see, after having some experience with the trinomial method, you probably see what we can do next. We have an 8X minus 3Y there on both terms, so we're going to remove that. We'll say 8X minus 3Y, and when I remove that out of the problem, I'm just going to scratch it out here for you. You don't have to scratch it, but I just want you to see what we're doing. We're pulling that out of the problem, and that leaves me with 3a and plus 5b, which is my next factor. So my final answer for this problem is 8x minus 3y times 3a plus 5b. So the grouping method's a little different, but it's already, kind of like something we've already done when we use the trinomial method. Okay, hopefully you've got it. We're going to continue to work on these in class. You have a worksheet that you should be able to complete the rest of now, and I encourage you to, strongly to ask questions if you're having some trouble understanding any of the methods we went through. But hopefully this will give you enough to get started on your endeavors of completing the worksheet. Have a nice day.